Hello students, let us continue the session on revision of the chapter Statistics and Probability. In the yesterday's session, we completed exercise 13.1 of NCERT exemplar. We shall continue with exercise 13.2. The questions of exercise 13.2 are basically true or false, and we need to reason out for the answers. The first question here is the median of an ungrouped data and the median calculated when the same data is grouped are always the same. Do you think this is a correct statement? Give reason. We all know that the median of ungrouped data and the median calculated, they will differ. They'll not be same always. Sometimes they can be same. The reason is the median of ungrouped data is calculated by arranging the data in an increasing or a decreasing order, whereas the median calculated in the grouped data, the formula is being used based on the assumption that the observations are uniformly distributed. That's the major difference. So let me mention here the median of an ungrouped data and the median calculated when the same data is grouped, not always same. Because the median of ungrouped data is calculated by arranging the data in increasing or decreasing order. But for calculating median of a group data, the formula used is based on the assumption that the observations are uniformly distributed. In the classes. Question number 2. In calculating the mean of group data, the group in classes of equal width, we may use a formula x bar equal to a plus sigma fi di upon sigma fi, where a is the assumed mean. A must be one of the midpoints of the classes. Is the last statement correct? Justify your answer. Here, according to the question, A must be the midpoint of one of the midpoint of the classes. It need not be. It's not necessary. So, like mention that not always. Assumed mean can be considered as any convenient number which makes the calculation easy. It can be any number. The basic reason why we do the assume mean is the calculation becomes easy. Question 3. Is it true to say that the mean, mode and median of group data will always be different? Just justify your answer. Mean, median and the mode, it can be said they may be equal if the number of observations are odd and are equispaced. If they are equispaced and if odd number of observations are there, then we can have all the three equal. So let me mention that answer not always, because they may be equal if number of observations are odd and are equispaced. You will have plenty of examples wherein we get mean, median and the mode of group data as same. Question number 4. Will the median class and the model class of group data always be different? Justify. Median and the model class may be same if the model class is median class, which is not always possible, because the number of frequencies may be maximum in any of the class. So it all depends on the number of frequencies. It may be maximum in any class. So this particular statement, therefore statement is not true. Fifth one, in a family having 3 children, there may be no girl, 1 girl, 2 girls, or all the 3 girls. So the probability of each is 1/4. Is this correct? Justify your statement. So this family is having 3 children. So the possible outcomes or the total outcomes will be like all the 3 can be boy where no girls are there. 1 girl, it can be of this type. 2 girls, or all the 3 girls. So the total number of possible outcomes is 4. The probability of each is not 1/4 because the outcomes are not equally likely. The outcomes are not equally likely. Therefore, the probability of each is not 1 by 4. Question 6. A game consists of spinning an arrow which comes to rest pointing at one of the regions 1, 2 or 3 as shown in the figure 13.1. Are the outcomes 1, 2 and 3 equally likely to occur? Here you must observe that the area of region 3 is double either of area 1 or 2, and area of 1 and 2 are equal. Therefore, the number of outcomes of region 3 must be or is double of either 1 or 2. Therefore, the outcomes of 1, 2 and 3 are not equally likely to occur. Question number 7. Apurv throws 2 dice once and computes the product of the numbers appearing on the dice. Pihu throws 1 die and squares the numbers that appear on it. Who has the better chance of getting the number 36 and why? So the total number of possible outcomes for Apurv, first let me write this as for Apurv. The total number of possible outcomes will be 36, in that the favorable outcomes will be 6, 6. This means that the number of favorable outcomes is only 1. Therefore, the probability of the event of getting 36 as a product will be the number of favorable out of the total 1 by 36. Now, for Pihu, the total number of outcomes is just 6, and the number of favorable outcomes is only 1, because 6 square is only 1 time. So the probability of the event of getting 36 will be 1 upon 6. If you look at the probability of getting 36 by Pihu will be of larger chance, it will be a better chance compared to Apurv's, because we have 1 by 6 which is larger than 1 by 36. Therefore, Pihu has a better chance. Question 9. A student says that if you throw a die, it will show up 1 or not. Therefore, the probability of getting 1 and the probability of getting not 1 each is equal to 1 by 2. Is this statement correct? Your reason. We all know that this statement will be wrong. The reason is the total outcomes will be 1, 2, 3, 4, 5, 6. There will be 6 outcomes. So probability of getting 1 will be only 1 chance out of the 6. And the probability of getting other than 1 will be 5 by 6. So they are not equal. So probability of event is 1 upon 6. Probability of not an event is 5 upon 6 here. So they are not same. Hence, the given statement is incorrect. Question number 10. I toss 3 coins together. The possible outcomes are no heads, 1 head, 2 heads, and 3 heads. So I say that probability of the number of heads is no heads is 1 by 4. What is wrong with this conclusion? Here there are 3 coins tossed. So the total outcomes will be all the 3 can be tail, 2 tails and 1 head. First one is tail, rest of the 2 are heads. First one head, second one tail, and third one head. It can be 2 heads followed by 1 tail, 1 head followed by 2 tails. Then this is another possibility, and the last chance would be all the 3 heads. So the total number of outcomes is 8. Here the number of favorable outcomes is just 1 because no head is present in only one case, that is all 3 tails. Therefore, probability of getting no head will be only 1 chance out of 8. Hence, given statement is incorrect. Question number 11. If you toss a coin 6 times, it comes down heads on each occasion. Can you say that the probability of getting head is 1? Give reason. Here a coin is tossed 6 times. A coin is tossed 6 times. So the number of outcomes will be 6. In total 6 events, number of outcomes for getting head will be 3. So the favorable number of favorable outcomes will be 3. So probability of getting head will be 3 upon 6, which is 1/2. Hence, given statement is false. Statement 12. Sushma tosses a coin 3 times and gets tail each time. Do you think that the outcome of next toss will be tail? Due reason. As the coin is tossed 3 times and gets tail each time, but it is not necessary that 4th time will be tail. It can be head or it can be tail. So the statement given is false. 13th one. If I toss a coin 3 times and get head each time, should I expect a tail or tail to have a higher chance in the 4th toss? Give reason. As we know that coin has got equally likely event, either it can be head or it can be tail. So next time on tossing, he will get either of tail or a head. So it's not possible. So the statement is false. The statement is false because 4th tossing we cannot predict its head or tail. 14th one, a bag contains slips numbered 1 to 100. If Fatima chooses a slip at random from the bag, it will either be an odd number or it can be an even number. Since this situation has only 2 possible outcomes, so the probability is 1 upon 2. Justify. Here, there are slips numbered 1 to 100. So that means that there will be 50 slips which are evenly numbered and 50 odd numbers. And the total outcomes are 100. So here, number of outcomes favorable for the event will be 50. So the probability of getting even or getting odd will be 50 upon 100, which is 1/2. Hence, the given statement is true, because this would remain same if it is even, or it would remain same if it is odd. That's all for today's session. We shall discuss the remaining questions of the exercise 13.3 in the next session. Thank you.